Good morning, everyone. My name is Mark Palmer. I'm from TIBCO Technology. Company's about $1 billion company. How many people in the room know TIBCO at all? Kind of what we do? Wow, okay. How many people love TIBCO? Please keep raising. Look, I'm the Senior Vice President of Engineering for Analytics, which for us means our Spotfire business, which is traditional visual analytics, and also streaming analytics. I was the CEO of Streambase we acquired 3 years ago. Then a lot of you know that we went private about 1.5 years ago. And I think one of the cool things about going private is you get to do some things where you get to start to take the long view on the business. And some of the interesting areas where we've been doing a lot of R&D is in the Internet of Things and Spark and Hadoop. So that's what I'm going to go through today, a little bit about what we've been doing that's kind of new with the platform, what we see are the use cases that our customer base are commonly using the TIBCO technologies for, but most specifically about obviously Hadoop and Spark. Was anybody at our user conference 2 weeks ago in Las Vegas then? Anybody here? Wow, okay, well I'm bringing the user conference to you because we had our conference in Vegas. We had about 3,000 people there. And these use cases are use cases that we've been seeing a lot, and I thought I'd bring them kind of as excerpts from those customer presentations. So that's going to be the basis of the talk, but I'm going to step back and talk to you a little bit about how we see the basic pattern of use before we get into this. So if you have been following the company, then you know the company acquired Spotfire about 7 years ago. So from a visual analytics perspective, we have a fantastic product there, and if you haven't seen it recently, the new releases of it have been really cool. We were actually, one of the other things we've done when we went private is we're starting to move all our technology into the cloud. Traditionally, TIBCO has been a very on-premise kind of company, right? But Spotfire is really the key. We have amazing geo-analytics functionality in it, and what we've talked about our overarching strategy is bringing that platform together with real time. So actually the keynote was very interesting, starting to talk more about IoT data and streaming analytics. For everybody that knows TIBCO from over the years, a lot of you know our founder Vivek Ranadive, who's been really talking about the power of now and streaming technologies for a long time. So it's great to see sort of the energy in the market come in that direction. So we've been building this, basically taking this view on our technology where you find important analytics within data lakes, you deploy that down to streaming technology, and then you take it all the way to the action component, which is where you're actually doing alerting and you're visualizing in real time what's happening as your models get scored in real time. And then that loop is the really important thing. So we view this as the basic platform that people need, finding observations, deploying them into the real-time fabric, acting on them, and then constantly churning and cycling and making them better. So this is where the whole machine learning obviously comes in. So I'm going to go to the next level of technical depth in a minute here. But conceptually, this is where we see a lot of the market moving for really streaming analytics in particular, but also real-time systems and enterprise real-time systems in general. So our view, if you decompose that down a little bit, there's really 6 stages that we see of processing. One where you're grabbing this information. And actually, so for those that have followed the streaming analytics market, Streambase, of course, was founded in MIT. This was my company that was acquired. We've actually seen an interesting trifurcation, and you'll see that in this slide, of the usage of it. The first is as really just streaming data preparation. So we've talked a lot, the keynotes talked a lot about ingesting data. A lot of our customers use now streaming analytics to grab moving information, and also information that's static, but mostly streaming. Cleansing it, normalizing, binning it, and putting it into Spark. In what we have, we release a, when we went private, we built an engineering team that is in my organization that now builds open source technologies and releases them to our community. So all the things you'll see here with this accelerator pattern are things that we've released through open source to our TIBCO community. So the HDFS, the Parquet, and HBase connectivity is how we get data into Spark. Next are, obviously analytics. This is really, for us, what we generally use Spotfire to discover important patterns interactively. Those models can then be discovered and deployed back down into the real time. So this is where, again, that general pattern of finding a pattern, figuring out which one's the best, which of the, if you're absorbing all your IoT streams into a big data lake, into Hadoop, figuring out which patterns are important, loading those into real time, then tapping off that flow of data directly into the streaming analytics component to score against the model tick by tick by tick. Every time the tick comes in, you can score the model, make decisions in real time, and continuously take action. You know, the other thing that I think a lot of our customers think about after you've been doing this for a while, right, is what happens when the model starts to go off piste, if you will, right? You have to constantly track that. So there's another component where in real time, once you start to deploying these models in real time, there's the element of actually watching them constantly and scoring them as the system runs. And then finally, for operations is the last piece of the puzzle, and I said before it was trifurcated, if you will, from streaming, where the streaming pieces fit first from just the data ingestion, then from the sort of traditional real-time action, and then also from the live monitoring and analytics part of the use case, right? So the whole visual analytics platform we see is very much evolving from only working on data lakes to also working on streaming information as well. Did you get all your pictures? Do you want one of me? Please do. If anybody, if you want to, I'm sure these, I'm sorry, for the room, these are all posted online somewhere, I assume, right? Yes, I think the answer says. Okay. Look, very quickly, just going through, I'm not going to go down to, this is kind of decomposing it down to the next level, the way we see the technologies that are important in this ecosystem, streaming data preparation. I'm just going to click through this. You can see the one important component that I didn't mention is the actual models themselves. There was a lot of discussion about H2O. We love H2O. We also love PMML. We also love, we actually have our own version of R that we've optimized to be real time. We call it the TIBCO Enterprise R runtime. We use R specifically all by its lonesome as well. It really, our view is it really kind of depends on the degree of real-timeness that you need. So that's an interesting offline discussion if anybody wants to talk about that. Streaming analytics, how it connects to the rest of the world, and model tracking. So these are just kind of a different functional view of what I actually just showed you. I think the important thing that vendors like TIBCO can do is make it easier to do this. Actually, this is the code that that you use in our environment. You actually saw in the keynote a lot of coding. We love coding. We're geeks. But for enterprise usage of Spark, one of the things our customers ask us for a lot is just make it simpler to do that, right? So can I have visual programming techniques? So like, for example, this Spark ML lib, you see here, you see an H2O model, you just drag and drop it on a palette. So I think the enterprise companies, I think, focus on this a lot, like TIBCO is simplifying the job of building these applications. And I'm going to skip through these two things because I'm going to get, I'll talk about this for a second. So our particular view on what we do and what I want the basis of this talk to be is really about automating real-time decisions, right? There's tons of the world of Hadoop, I think, is largely dominated by people that are trying to figure out, information about from their data lakes, right? We saw that a lot, again, on the main stage. But how do you then automate based on that? And this is what's happened, I think, predominantly on Wall Street a lot. And there's a huge, I think, resistance to automation in general in most enterprises. So I spend most of my time talking to CIOs, talking to CMOs about the business side of using this technology. And the biggest obstacle that we usually see is not actually the technology at all. It's actually the business driver and people's resistance to automation. So that's why I use this slide, because it's actually, I think everybody gets up on a main stage and they talk about the opportunity and the threat of real time. We see both, but we also have to think about how do you actually implement these systems, which I will talk about. So let me go through these use cases for you. We'll start with one that has been very common. I think one of the speakers on the main stage talked about the proliferation of connected vehicles, right? So we've certainly observed that as well. Modern vehicles are now mobile devices, right? But the problem is that still most systems most existing systems take that information and put it into a data lake, right? Now that's kind of rear view mirror thinking about the processing model. But then the meta problem from a business perspective is that millennials, I have 2 kids, they're 15 and 13. Our kids are basically born with cell phones, weren't they? So they expect everything now. They expect to know, they actually do know where I am right now. They can track me on Find Friends. They expect to order everything online. They expect to do all their banking online. They expect to know when they order something that it's where it is in real time. So I think this is an important canonical problem. We found this. Dutch Railways was one of our probably about a dozen or so customers that have deployed large-scale streaming systems based on data lakes that are predominantly stored in Hadoop in some form. And the problem that these guys are after is, how do I take a very complex network that is represented by a train? How do I take advantage of the connection, the sensors that are emitting information, and make some decisions in real time and predict when I'm going to have problems? Okay, so I'm going to actually take you through the architecture that the Dutch Railways and several others have implemented. So it's in some ways similar to the picture I showed you before, where you've got information flowing from the left to the right, event-driven rules and predictive analytics in the middle. Down the bottom, you have analytics, and in the middle, of course, you have Hadoop and Spark, right? And that's that circle that I was describing before, where you're actually taking all that sensor information, you're analyzing it in a data lake, and then taking the models that you discover and deploy it into those blue blocks in the middle, right? And in the blue blocks, that's where all the cool stuff happens. That's where you can predict when maintenance needs to happen on trains. Imagine you're processing thousands and thousands of trains simultaneously in real time. How do you know that there is going to be some clustering of the trains, that they're getting too close together, you have to slow down? That is actually the key predictive analytic problem to solve for a large transportation authority. And then how do you monitor it your top right, in real time? How do operators actually see what's going on and make adjustments on the fly? And then when you actually have a problem that is some sort of maintenance problem, like you have an indicator that that maintenance needs to get involved, how do you actually manage that workflow through the process? So I'm actually going to show you a bit of their system and how those pieces actually fit together with a little bit of a demonstration here. So within these accelerators that we do, we build simulators, so you can actually simulate the real-time behavior. And what I'm going to show you is information being transmitted in real time from these thousands of trains. We introduce a bad weather alert or event, and that's going to impact the system, right? Imagine, again, all those railways that you're monitoring in real time. Any one condition will follow and create problems in anything that's connected to it. So in real time, we want to detect that and then make take some action so that the original path gets corrected, and then we don't affect other systems trains as they're running. So you're actually going to see here, this is a live view of that system that is attached to both the sensors, but also importantly the analytics and the rules running in real time as the trains flow through the system. And you can see it's an interactive dashboard. This is a technology that we have that we call the Live Data Mart. I'm going to break it down. It's very hard to look at a real-time system and understand what's going on, right? So I'm going to take like kind of a moment in the life of this so you can see how things work. So at first we have all systems go. Everything here powered by sensors flowing into this live view of what's going on. The front end is HTML5, of course. So for streaming analytics, and there's lots of streaming technologies here, the trick is how do you take the analytics that you run and connect it to a visualization? Okay, so this is what you're actually showing here, a connection between the rules that get fired in the back end and the front end that you're seeing up top. You know, we introduced a simulated event. We fire alerts, basically real-time systems in these kinds of scenarios and use cases. They are like one large exception handling system, right? We are firing alerts, but you're actually seeing, and this is actually the real key, right? All that real-time dashboard, you see these moments where you can actually see. In this case, I'm going to get down off this. This view that you're seeing, this tan line, is the scheduled arrival of this train. The gray line is the scheduled departure for the same train. And what you're seeing here is analytics running and predicting. That red line that you can just probably barely see from the back is actually the prediction of when the train's going to arrive. Right? So this is what we're interested in real-time systems. So the line is calculated based on analytics that were discovered through the lake. We've deployed them into the system, into streaming analytics. And now we can visualize them and see that this is a problem. So again, these are big exception handling systems. So I think raising exceptions through a visualization is super important. Those are raised to operators, and then they can go in and they can do something about it, right? So this is, in this case, weather delays or maintenance events tend to delay trains, but you can actually go in there manually and figure out, okay, this one, the weather delay is just a forecasted delay, so I can actually let the train speed up and you can resume operations. So this kind of system is very common right now throughout the world. We're seeing transportation authorities all over the place moving to this model so that they basically could keep the trains safer and running on time. Okay, so that's kind of use case number one. The next one we see a lot is in what we generically refer to as intelligent equipment, right? This is very common in oil and gas. And actually, I think that is that's the example that I'm going to show you, yes. And what we see from an analytics point of view is customers, companies going through sort of a progression of dealing with maintenance problems. And again, this applies to just about any company that has large industrial equipment. You start with reactive and you go all the way to proactive, right? The proactive is the predictive real-time architecture that I showed before. So in the oil and gas industry, this is generally driven by sensors that are on all sorts of equipment, right? It's not just an oil well. A lot of times you'll see, presentations like, well, we're going to monitor an oil well. There's tons of equipment in an oil well that constantly emits sensor information, often through SCADA systems. This is actually an interesting one where most of the analysis is, we are just starting to see this, our customers use Hadoop more. Is usually not, though. It's usually the repositories that are built by the SCADA system providers themselves. So for example, OSI Pi, GE has an environment to do this. But increasingly, we're seeing that same pattern, the same technical pattern be applied to sensor data emitted by SCADA systems as well. But here's a bit of that use case now, right? So imagine, again, now not analyzing trains, but you're analyzing the electrical submersible pumps that are embedded in the ground, right? And this is a map through the Spotfire Analytics dashboard, where you can see at one glance a sort of a temporal representation of the signals coming from the sensors across all of these oil wells. And you can see we've marked and identified some of them as having potential problems. And this is the point where a lot of discovery is happening right now in oil and gas. How do I understand what are the predictive signals that a well is going to need maintenance, right? It's a huge problem because it doesn't just affect the maintenance costs, right? It affects production, right? Like an oil well goes down and needs help. If you're not scheduling maintenance ahead of time, then you're going to elongate the time that you're not pumping oil out of the ground. It's a huge, huge problem for R&D and I think analytics in general. So here you can actually see, you're looking for signatures of problems. And here we drill down on one of the pumps that doesn't have any issues. And you can see the small lines above and below here, which represents the sort of the normal range. So this is the discovery process within Hadoop, right? This is the discovery process, looking at all that sensor data, and you're saying, okay, there are my lines of, say, normalcy, and here are my lines of abnormalcy. So you can start to say, okay, exactly fine. I remember we have a chief data scientist, his name is Michael O'Connell. He worked with one of the oil companies for about 3 months to sort of figure out some of the predictive signals that lead to failure. And after 3 months, he came back and he said, we finally found an 85% predictive signal of failure. And it was really, the trick was finding exactly the right line in combinations of conditions in the sensors that went bad, right? So, for example, decreasing voltage and increasing temperature is a really bad combination. It represents a short, right? So those are the kinds of things that when you find them within your history, then you can deploy them into real time, and all of a sudden you have a different view on your oil feed. You can in real time monitor for those particular conditions you found within the data lake. And this is sort of the other view of that. You can overlay that into the stream of sensor information and take that signal and watch for it. Now, in this case, and often in oil and gas, we see R used a lot because that's sort of a common modeling environment that they actually like. I'll describe a few others that have been more amenable to using H2O as well. So this is the kind of view of what you're doing, right? I mean, I think the streaming part that's really important is looking for these patterns of events that come in moving and sliding time windows and different levels of aggregation where you're looking for these patterns that you find in the historical data and deploying them into the stream. So this is really, I think, emblematic of streaming analytics. A lot of the use cases that you're seeing here, it's the same thing that happens for the trains. Should I try to figure out if that train's going to be late? So this is the architecture. Again, it looks pretty similar to the other one, but it's different in a lot of important ways as well. The data comes from different sources, things like OSI Pi. WITS-ML is an important area that we build connectivity to absorb these events. Also engineering diagrams. So all this data being pushed into this real-time system for streaming and batch analytics. Different kind of rules, same kind of pattern. You've got your analytics below, you've got your monitoring up above, and you've got your cases as they work through the system. So again, Spark being used to both discover and then model and train, score, and then deploy the real-time algorithms. Algorithmic loyalty, my gosh, I think I'm covering the keynote here in my presentation, the different use cases, maybe a little bit more detail. North Face came to our user conference, and what they talked about was how did they go through and slice and dice their customers, right? So this is very much a Spark use case that they used. They have this dashboard which you follow through progression of taking your customers, looking at all of them, and then segment it and run various models, machine learning models against it iteratively so you can find exactly the right combination that you want, and then again, deploy it into the stream. So this continuous digital loyalty. Now here, again, the events change, right? The events here tend to be more IoT data from devices that people are wearing, to loyalty information, to social media information. So again, the event streams tend to change here, but the overall model of finding analytics, deploying them into the real-time stream, and also being informed by loyalty systems in the middle is an important, I think, variation on that. The other thing that's different in generally the loyalty context is this whole API management space, right? Where you now want to expose to partners, both in your supply chain, but also directly to consumers' mobile applications that are exposed by APIs. That's a little bit of a different variation on this architecture. Okay, predictive risk and compliance, one of my personal favorites. If people are familiar with Streambase that was acquired, we spent a lot of time with the capital markets. And about 3 years ago, I think everybody knows about algorithmic trading on Wall Street, but what a lot of people don't notice is that you can actually lose money just about as quickly as you can make money. And this happened to Knight Capital, where they literally lost $460 million in under 40 minutes because an algorithm started trading against itself, right? So as people, and the reason I don't like to tell this story, but the reason I use this anecdote is that when everybody thinks about real time, it's like, oh, great, we're just going to make everything real time, we're going to automate everything. You have to think about the other side of it, right? Risk management, compliance, monitoring systems. Most companies don't think about this first when they start to go digital with their systems. So the thing that's important here is actually providing that real-time visibility. Now this was shown in the other architectures before, but I think it's really highlighted from what's happening in capital markets. This is one of our customers that was at the conference called Convergix. They were a division of the Bank of New York. And they built this system
that monitors all the orders that they actually, ConvergeX runs one of the largest digital trading venues in the United States. It's the 6th largest ATS in the US. And what they do is they tap into the streams of orders and they look, their predictive analytics, the things in blue in the middle, right? For people that have been in the capital markets, you know what all these things are. There's large orders, they're looking for layering, spoofing, wash trades. Wash trades are actually interesting in the old days of trading. Traders used to actually get together, when everything was manual or done by phone, they would get together and they would actually coordinate and do 2 counteracting trades that washed each other out. Right? So I sell $1 million of IBM, you buy $1 million of IBM. We actually wash out the 2 trades with each other, but it spikes volume. It makes the markets look hotter for a particular stock, and then you can take advantage of that. Anybody watch Trading Places? Kind of similar thing going on in the movie with Eddie Murphy, right? But in a slightly different way. That's, by the way, illegal. And it's important for companies now that run these digital trading systems to watch for this in real time. Because the problem is that algorithms could do it much faster than Eddie Murphy and Dan Aykroyd could in the movie, right? So this is a really important system and architecture in the capital markets now. And it's also one I think everybody can learn from because it's also very similar to what the oil and gas system was before as well, watching for those signals that indicate that a well is going to need maintenance in real time. So constantly looking at the stream of information and finding those important signals in Hadoop to discover the important patterns and exactly the sensitivities that need to go into those blue algorithms in the middle. The other interesting thing about this particular system, and it's pretty good scale, right? I love these keynotes when people they say, oh, billions of events a day. Billions is actually not very much. 51 billion is a lot. This one's 51. But billions is, for most of these real-time systems, it actually, a billion or 2 doesn't make them sweat, even with just a quad processor for this kind of a system. So, but an important use case, I think, for all systems that become automated. There's a technology here which is starting to gain some popularity in the open source community as well to visualize what's going on. So this is actually a data mart that's not a data mart. It's actually an in-memory live data mart with continuous query processing. I think an important thing that a lot of people don't know about yet, but it's all happening and being used heavily in Wall Street. Live flight optimization. Everybody here has been personally touched by this. United Airlines was just one of our customers there. JetBlue was there, and Lufthansa. Tons of airlines. You do this real-time stuff. You all know this, right? You check in with your mobile phone. Things are more real-time now. They don't really work. Sometimes they don't work so well. But those are all the airlines moving their flight operations to being more real-time and using big data repositories. And you actually see, these are actually literally the slides from United's presentation. We can see this sort of cluster on the left where they talk about getting multiple data sources, right? Using big data in Hadoop, drilling down and finding patterns, and then automating actions associated with the patterns that you find. So a lot of these systems, actually the airlines have been quite advanced in this combination of looking at history and then figuring out what's going on in real time. And this is one of the United internal systems that they use to keep you up to date when your plane's delayed. Okay. The other one is really sort of transaction optimization and monitoring in general. This is a business system that was built and presented by Morgan Stanley last week. And their problem is, if you think about what Morgan Stanley does, they're taking orders from thousands of places at once electronically. They just get messages to buy and to sell stocks and foreign exchange, et cetera. The problem is understanding when one of those trades is broken, or when a system's broken, or when a router is running hot and not able to, therefore, execute a trade in real time. The problem is that most banks still today, it takes them about 3 to 5 days to figure out when there's a problem. Of course, the client notices it first. And probably a lot of you have businesses or work in businesses where you have clients that are watching their stuff very, very acutely, right? So once again, finding the patterns that lead to, that predict failure, but then be able to visualize it in real time. And this is actually one of their charts where they're using real-time charts and heat maps to figure out which clients have a lot of flow and which flow is being affected. In red here, you can see the hot spots are in red. Those are trades that aren't operating the way they should. Maybe they're stuck, maybe they are in a router that's had a problem that needs to be taken out, which actually happens quite a bit. They use this chart is actually the one that was mapping and correlating their router infrastructure to trade flow. And they went from having about 4 or 5 routers go down every week to none because they just took out the problem by using this and actually using those predictive signals is when the system was going to go down. It's a tremendous case study, and it really changes the relationship between a company that's providing a service that's electronic and their clients by finding problems before they actually occur. Then the last use case that I'll mention is one that the press release is actually going to go out next week on this, so I'm a little bit ahead of it. But we've been working with them for over a year. Is there anybody here from the UK? No. Wow. Well, okay. So if you're in the UK, and by the way, this is I don't know how much of this is recorded or whatever, but 80% of the parcels that get sent to the UK by the Royal Mail, they don't know where they are. So they are really transforming the way they look at those systems. And I just thought, I like to end on this because, I've got sort of these Wall Street stories and everybody's like, wow, well, Wall Street's always investing and doing all these cool things. Well, my gosh, when the Postal Service is starting to use the Internet of Things and real-time tracking and a real-time architecture like this, which is just like what they use on Wall Street, then you know that this is actually sort of, it's not just hype from vendors about what's happening on these systems. So this one's a little bit more complicated, but what they have initially done is start to tag all the parcels that go through in their entire infrastructure. And what most people's journey toward being real time just starts with understanding what the heck is going on. So that's the top right corner. Is what is happening in the flow of a parcel when it goes through the system in the UK. Lots of manual processes still, but now that they're tagged and monitoring things in real time, they are starting to absorb and build this big repository so that they can really understand and then react appropriately when there's problems. But then the rest of the architecture, it's drawn differently, but it's pretty much the same, right? It's pretty much the same where you got events coming here from the web. You've got customer support systems that go through mobile applications like I was showing in that first slide here. So you can check on the status of your package. You can sign up for alerts. That architecture all runs through APIs that go out to mobile devices. You've got these rules that fire and these streaming analytics that are born and discovered from the Hadoop infrastructure and analytics. And of course, you've got sensor data coming in here in the corner. So they call this the Postal Service Internet of Things. And I think, once again, it shows you, that even the Postal Service is getting pretty aggressive in terms of innovation. Okay, so those are the 7 of my favorite use cases that I saw at our, I see systematically through our customer base. I think I've actually got a few minutes left in case anybody has any questions. Anyone? Yeah?
The data management is necessary to get these analytics done. Where does that happen? The transformation.
Yeah, so the question is the data management, the transformation of the data as it comes into Hadoop. Actually, if you, I would have to skip all the way up to one of the first slides. Look, it's a huge question, right? Like all of the streaming data management is one that we see use a lot of streaming analytics for that because, and there's a lot of technologies that are evolving in the open source space for that as well. Sort of the batch-oriented process of, we still see most of the traditional vendors doing that, right? You've got Informatica, you've got IBM Technologies, you've got, I mean, most companies have a pretty sophisticated sort of data management, data ingest infrastructure. We tend to look at it much more, and that's specifically for Hadoop as well. I tend to personally look at the sort of the streaming side more, which is where we've put a lot of energy into building the right connectivity into the Hadoop. So that's interesting. It's a big topic, but that's sort of the top of it. Yeah.
In terms of predicting something and taking the automatic action for it, so I mean, what is the thought process now? Because I mean, if predicting is one thing, but then actually taking the automated action, you could like you explained, right? In terms of Wall Street, if you just take an automated action, you could end up losing hundreds of millions. Right? What's the thought process?
What's the thought process? Be very careful. No, look, I think that's why this the level of sophistication that other industries have done is actually rising quite a bit. So that live data mart that I showed before was a direct response to that was created just 3-4 years ago. It was one of the first ones. Now there's a lot more sort of real-time monitoring, streaming monitoring platforms, right? And that was a response to, hey, we can no longer wait for reports that run twice a day, right? And even today, a lot of trading is still governed by that, but the regulators are starting to mandate that they actually track as aggressively as they trade. Not happened yet, but so that alerting and exception management system architecture for real-time systems, I think, is sort of the preeminent area where a lot of research is happening now. The other that is often left not on this chart is actually all those decisions being fundamentally and by default run back into Hadoop, right? So the forensics are possible to, so these arrows, actually this one arrow is actually drawn incorrectly, right? So you're aggregating, you're looking at information, and then whenever you make real-time decisions, it always goes back in. So that forensic loop we see happening a lot more, but that is the first slide that I showed, right? That tie back in, right? So you go from analytics to automation to action, and then the loop kind of comes back in, often through the data repository for looking back at the data lake of what you did right, what you did wrong, and then continually refining. And I actually think that that's one of the most interesting areas. There was a study that was done by an analyst firm on Wall Street that said that an algorithm is effective for no more than 6 weeks in the equity space, right? So you constantly have to be making your algorithms better based on what you see in the automation. Maybe one more question? All right, I guess that's it. Well, thank you very much.